Hello, welcome to this lecture, part 13 of Laplace transform. So in this we'll find the inverse Laplace transform of some functions. So in this and maybe the next 2 or 3 lectures, we'll be finding the inverse Laplace transform of certain functions. So which will be very useful in the course of study of process control. So these functions will be used more often. One or the other of these functions will be used quite often in the course of process control. So let us see what are the inverse of these functions. Well, the first function is 1 by tau s plus 1. F of s equal to 1 by tau s plus 1. This can be written as, if I take tau out, tau into s plus 1 by tau. Okay. So now if you take inverse of this, inverse Laplace transform, we're going to get tau is a constant, okay, and the rest of the terms is of the form 1 by s plus a. So this is going to be e power minus t by tau. So the inverse of this function is by tau e power minus t by tau. Simple, it's a direct formula. There is only one term, so direct formula. So the inverse of this function is f of t equal to 1 by tau into e power minus t by tau. This one. Okay. Now let us go to the second function. So second function is this, f of s equal to 1 by s into tau s plus 1. So if you see the previous function, it is the same function divided by s. So here we will use the formula. What is if you have f of s by s, and what is the inverse of that? Inverse of this is integral f of t dt from 0 to t, right? So we'll use this formula. Inverse of L inverse of f of s by s is integral f t into dt. So this function is nothing but the previous function divided by s. So what will be the inverse of this? Is going to be integral of the previous function. Previous function is 1 by tau e power minus t by tau dt from 0 to t. Right? So what is the integral of this? 1 by tau is a minus sign, 1 by tau into tau into e power minus t by tau the limits 0 to t. So tau cancels. So if we substitute the limits, upper limit is the same, and lower limit is 1. So this is going to be simple 1 minus e power minus t by tau. So f of t is going to be 1 minus e power minus t by tau. The inverse of this function is 1 minus e power minus t by tau. So the inverse of this function is this one, f of t equal to 1 minus e power minus t by tau. Okay. Now the third function is this 1 by s square into tau s plus 1. So compared to this, so this has got an additional s factor in the denominator, s square. So we can use the same formula. We'll use the same formula here also. And so what will you do? Take up this and integrate. Okay. So f of t equal to, so L inverse of this function is going to be the integral of what we got previously. What did we get previously? 1 minus e power minus t by tau dt from 0 to t. So if we do this integration, what are you going to get? 1 is t plus tau to e power minus t by tau between the limits 0 to t. So if we substitute the limits, t plus tau, first upper limit is the same, and the lower limit minus tau. Okay. So if you, this is the inverse of this. If you rearrange this, on rearranging this, the inverse of this is, you get this. I just rearrange this. So the inverse of this function f of s equal to 1 by s square into tau s plus 1 is t minus tau into 1 minus e power minus t by tau. Now alternately we can also do this, find the inverse Laplace of these functions, this and this, by means of partial fraction method. You can split this up into partial fraction and then do. Since here it is more convenient and easier to do this, to find the inverse by using this formula. So we did by using this formula. You can also do by partial fraction method. So I'll just illustrate for one of this partial fraction method. For example, for the third one, if you split this by partial fraction, 1 by s square into tau s plus 1, if you split into partial fraction, a by s plus b by s square plus c by tau s plus 1, because s is a repeated root, so you have to write two constants here for s, and one for s square. So if you take LCM, and if you want to evaluate these a, b, and c, so let us substitute values. If you substitute s equal to, put s equal to 0, then what do you get? As, this becomes 0, this also becomes 0, so you get b equal to 1. Next, what do we do? So let us put s equal to minus 1 by tau. We put s equal to minus 1 by tau, this term becomes 0, this also becomes 0, and here it becomes c into 1 by tau square equal to 1. So this means c equal to tau square. So you get a equal to 1, sorry, b equal to 1, c equal to tau square. Next, to get we got b and c. Next, to get a, so let us substitute, let us compare s coefficient or s square coefficient. We want to get a, right? So we can also compare s coefficient. Okay, s coefficient, if you compare, are you going to get anything? You will get as plus b tau. A plus b tau equal to 0, and b is 1, so b is 1 here, so a equal to minus tau. Okay, b is 1, so if you substitute b equal to 1, a plus tau equal to 0, a equal to minus tau. So you got a equal to minus tau, b equal to 1, and c equal to tau square. So if you substitute these terms, fs equal to minus tau by s plus b is 1 by s square plus c is tau square, right? Tau square by tau s plus 1. Now if you take inverse, take Laplace inverse, we get f of t equal to, first term is 1 by s, so minus tau, second term is 1 by s square t, and third term is 1 by tau s square, tau s plus tau square, and 1 by tau s plus 1. Earlier we found earlier 1 by tau s plus 1 as inverse of 1 by tau s plus 1 as what did you find? 1 by tau into e power minus t by tau. That is here. We found here first function is 1 by tau s plus 1. The inverse is 1 by tau into e power minus t by tau. So if you substitute here 1 by tau into e power minus t by tau. So if you simplify this, you get the same. You simplify this. If you simplify this, you're going to get this. This is t, and then this is tau, and this tau square and tau I had cancelled, tau I written, t minus tau e power minus t by tau. And if you rearrange this, you're going to get this one, or this. So this is inverse of, which is the same as before, t minus tau into 1 minus e power minus t by tau. Same thing here, t minus tau into 1 minus e power minus t by tau. So other function, second function also can be done by split by partial fraction method. I leave that to you as an exercise. So right here we are seeing three functions, 1 by tau s plus 1, then 1 by s into tau s plus 1, and 1 by s square into tau s plus 1. We have found the inverse of these functions, three functions. The next lecture we will take up more functions and find the Laplace, inverse Laplace of those functions. I hope you have understood. These are simple functions, so I don't think there should be any doubt in this. So if you have any doubts, you can write in the comments section below, and wait for more lectures on this Laplace transform, more functions where we'll be finding the inverse Laplace. Okay. So hope you understood this. We'll see you more. Till then, bye.